we're going to have three instructors: Silvia Chaez, Engineering and Computing System; Nicolas Antoniello, Senior Manager for the region of LAC in ICANN; and Santiago Baggio, Electronic Engineer specialized on data networks and computing in academic areas. So with them, well, you're going to be working with them with what you saw this morning. So please feel free to ask questions and to interact. So I'll give them the floor. Nico will explain how the lab will take place. Good morning, everyone. I can't see you because there are huge spotlights. It's like having to give a presentation at a football stadium. So, to organize this lab, for this lab, you'll need your laptop, your computers. It won't work in a tablet, and in your mobiles it will be impossible because you need the command line. So you're going to have a computer, a browser. If you have a VPN running, I suggest not using it because the lab uses a sort of SSH on HTTPS, and sometimes they don't run along together when the VPN is working. So before we start, let me ask you, could you please come closer and sit down here so that everybody is closer, because you're all scattered all over the room. Here in your black tables you can sit down, you have sockets, because at the back you won't have either. And the lab, it takes 4 hours. So we're going to be here for 4 hours. So I invite you again, whether you use the computer or not, please come closer. If you are not so sure about it, well, think it over. Well, let me explain what today's lab is going to be about. This morning, you had several presentations. One specifically was, what was the name? RPKI and BGP. Security for network operators. And Erika and Guillermo were in charge of that. And they talked about BGP and security, and especially the standard RPKI, how it works, basic concepts, everything about RPKI. You're experts now. So what we're going to do now is to implement it in practice. So you'll have a lab where each of you is going to be given a router and a customer. The customer is a device that is connected to one of the networks that is connected to that router. So we are going to control a central router that will work as the router of an IXP, of an internet exchange provider. So each of you're going to control your border router. And what you're going to do first is each of you, well, we're going to do this all together. If you have no previous experience, it's okay, because we're going to do it together. And you have all the commands written, and we're going to explain what we'll do it, why, and then we'll do it. So you're going to configure your border router, and we are going to configure your BGP between that and the central router of the IXP. The spotlights are too bright. I'm afraid of falling. That's why I asked them to turn the spotlights off. Well, so as I was saying, you are going to establish a BGP session, and then we're going to apply some security guidelines, and then we'll see some things. We are going to simulate an attack scenario. You're going to see what that is, and you're going to apply everything you learned this morning on RPKI. You're going to have to apply filters, BGP filters that are RPKI based to act against that attack. And then we're going to identify what kind of attack it is, and we're going to see whether you're mitigating it well, and you'll see that things resume their normal operations after you do that. Well, for those of you who were not here this morning at the tutorial, let me give you the background. What we want to do with this lab is to show you the configuration, how it can be done, first manually, and then through automation, through Ansible, to enhance the security with the BGP protocol. So the important thing about this is to know that we have many problems in routing security. And those of you who were here this morning, you may have seen that you have route hijacking, route leaks. So there's something that we can do that we have available. Well, we can use filters that we can apply, so you can see hands-on what you saw this morning with Guillermo and Erika, who are with us today too, just in case you have any doubts of what was said this morning. So okay, so some general clarifications. First of all, the lab is not simulation. The tool we are going to be using is not simulated. We are not simulating routers. You are going to control a soft router, an FRR. It works perfectly, just the same as any other router that you can find in real life. That router is really connected to the internet. And you'll see that as soon as you establish the BGP session with the IXP, you're going to start receiving routes. The routes you'll start receiving are actual routes of real internet, the so-called partial routing. We won't inject each of your routers, the entire router table in the internet, but just a small fragment, because the complete table is like 1.5 million routes if you put together IPv4 and IPv6, or it could even be more than that. So basically, in the lab infrastructure, we have 100 groups executing and 100 customers. If we multiply times the memory for 1.5 million, we'll exhaust the entire platform. And that is why we're going to work with a partial view of all of the internet routes, but they are real routes. So as soon as we connect the router with the RPKI validator, well, that one too is real. And you're going to start visualizing all the blocks exactly as you would in a real operation. The idea is that at this lab, we're going to it's a real life operation. We're not simulating anything. Well, so we invite you all to join us. It's very easy because we'll guide you by your hands. If you don't feel comfortable, some people may start checking their mails. No, but please focus here and don't be afraid. This is an opportunity you have to do something hands-on at the event. So we'd like you to engage in this. To make you more comfortable at the lab, if you want to come closer, you can come to these tables here in the front rows. You'll be more comfortable, and it's easier for us too, as we give you the routers. A couple of things before we start. We're going to do it as follows. Each one is going to be assigned a group number. You'll have to write it down, because that will be the number that identifies you at the lab the rest of the afternoon. One is going to have 10, 11, 12, 13, and so on. Raise your hands if you are planning to do the practice, just to have an idea. Wonderful. So, when you're asked to raise your hands, please do that with as long we can't see it. But I'm going to ask the people that are checking. As the lab is limited, those of you that are remote are going to be able to follow the entire lab, but you won't be able to do the exercises. So now we're going to ask you if you can stop the video. For those of you who are connected, remote, and the idea is that only the people here will have access and not those that are remote. There you will have, then afterwards you'll be able to see it. Before we start, once you have access to the lab, we'll go all together, step by step. I'm going to be the bad cop, because I'm a technician too, and we as technical people, we love to go a step earlier. That is why we don't control the pumps, because we would. So try to go all together. Don't go faster than the rest, because that's the way it goes. So once you have access to the lab, you have a single username and password, so you can, but please do not interfere with some other group. So as soon as we assign you the group numbers, make sure that you're only using the lab that belongs to your group, so we won't be stepping on other people's feet, and because we'll have problems. So I'm going to ask if you can stop the streaming. Please let me know when it's no longer streaming. So if you are far, if you're remote, you're going to stop this, and then we'll resume. Stopped? Okay. So now the credentials. Santiago and I will assign the groups.
So transmission has stopped, but you can see on the screen what we'll be showing. We cannot see this on the screen and have the transmission at the same time. Okay. We had expected that. So we'll tell you the username and the password. That's an issue. Okay. So we have a serious problem here. Is there no way of not transmitting this and sharing the screen what I have over here? You sure? I can show this here. There it is. These are the credentials to access this. Don't access this lab, please. This should only be done by those who are present here. The others can follow this remotely, but you cannot access this because you won't have a group assigned to you. So open your browser. If you have Chrome, better. And if you don't like Chrome, and if you don't have that, use any. I say Chrome because the one that we have tested most, and we know this works well, but it should work with any browser anyway. And this is from your laptop. From a tablet or from a mobile phone, it's impossible to access the lab, among other things, because it's very difficult to type command line in your mobile phone. So URL is, it doesn't matter if you put HTTPS or not, it will redirect you. Just write lacnic43.de-labs.training, and they'll ask you for a username, which is the one you have here, lacnic43, and the password is the one you have over here. And bear in mind that this is case sensitive. It's all upper caps, ICANN25 at lacnic43. So I'll give you a couple of minutes so you can access the lab. So once you enter your username and password, just wait there until everyone has a group number assigned to you, and then we can go on. You'll see a whole list of groups in a beautiful screen with a very unattractive design. It's just text. If you have any issues accessing, just raise your hand and we'll help you out. Just a couple of minutes so that you can all access. If you don't have a laptop and would like to do this, you can sit next to one. Either you, if you know or do not know the person next to you, you can do the lab together. So part of the interesting thing of these events is that you meet new people. So it's an excellent opportunity to get to meet someone. Those of you who have just arrived, if you wish to take part in the lab, I suggest you come up front here, sit at this table here. You have power here. If you're running out of power, you don't have any sockets back there, but you do have in the tables up here in the front. So please take your seats here. There's plenty of room. Is that microphone working? A question. Those of you who have been assigned to a group and if you're in a group and managed to log in correctly, please raise your hand and keep your hands raised. Thank you. Now, from those of you who have just arrived, doesn't have a group number assigned to you? Anyone with no group number assigned? Who's missing a group number? Over there and over there too, okay? So for those of you who have just arrived, once again, open your laptops, open a browser, access this site here, lacnic43te-labs.training. This is a username, this is a password. And Sylvia is assigning you a group number, which is the one you will be using throughout this practice. Who doesn't have a group number? Show of hands. Who doesn't have a group number? Oh, there. He doesn't have a group number. Okay, thank you very much for your patience. This is a complicated part of the session. The rest is very easy. So let's be patient, bear with us a couple of minutes, and we'll start. And this is going to be very, very technical. Whether you are technical techies or not, this will become technical. So those who are not techies will end up being quite techie. These guys who have just arrived, ask them if they managed to log in. Otherwise, we can continue, particularly the URL and the username and password. So, did anyone have any issues logging into this site over there? Sylvia, can you help them out?
Los que llegaron recién y todavía no pudieron.
Those who have just arrived and couldn't access the username and password, take a picture of the screen. I will be removing it in 10 seconds time. So take a picture of this so you have your username and password so we can continue while you access this lab. So one of the advantages of you all having a mobile phone. So now let me share with you what you should be viewing once you access the laboratory. Once you access the laboratory, you will view something that looks like this. All right? So the list of the groups, and right at the top you have labs, ABRIT, and RT passwords. What we're going to use now in the first part of the lab, the first thing I'm going to ask you to do is to click where you see Lab Abrir. You will have a new screen that opens up in this browser with the letter of your laboratory, with the list of all the sections and the information that will be available. We're not going to use all these in the laboratory. These are just some tutorials of how to install and configure the fort. For the purpose of this lab, the fort has been installed and configured and is already working. In a couple of minutes, Santiago, sometimes I call him Colo. If you hear the name Colo, it's Santiago. It's the same person. Okay, Santiago will tell you about the basic fort configuration and which are the most important parameters for this configuration. But if you'd like to repeat this lab at home or in your organizations or in a lab environment, these are tutorials you have in English and in Spanish, and it shows you how to, a step-by-step guide to install and configure a Fort Validator. From all that information you have over here, what we're going to use in this first part is the one that is in Spanish, Guía de la Práctica Interconexión. It's practice guide for RPKI. It's in English, Spanish, and Portuguese. Interconnection and RPKI practice guide. It's the third starting from the bottom. So I'm going to open this one over here that is in Spanish. So you click there, and this takes you directly to the practice guide. This is the one that we will be following all along this laboratory practice. So let's go back to the screen where we had the list. Now look up your group number and access your specific laboratory. Look up which is the one that corresponds to your group. I'm going to use group number 1 that is not listed here. And how do you know whether this is the correct place? Because right at the top, on the left, you have the group number. In my case, it's GRP1. If you are group number 15, it's going to be GRP15 or 25 or whatever. So be sure that you are in the correct group. Now this is a network we're going to use, and that each of you has. You all have these devices in your networks. Each of you has a router, which is the one that has RTR-X. And throughout the practice, whenever you have an X, you have to replace this with your group number. In my case, RTR-X would be RTR1 because I'm group number 1, which is the one that is shaded in yellow in the middle inside. And that router is your border router. Each of you will have a border router under control. That is one that is connected to 4 different networks. It's connected to the network in red right at the top. The next one is one that is like dark blue, one is in purple, and the green one right in the bottom. The red network is the backbone of the laboratory. That is one that physically interconnects, or logically in this case, interconnects each of the border routers of your border routers with the central router of the traffic exchange point. So this would be like the wiring which your border router in the point of presence in the traffic exchange points, and the central router for the traffic exchange point. So this is what has been implemented in the red network. And the traffic exchange point has a central router, which is the one with E border RTR. That's a central one for the traffic exchange point. And the traffic exchange point also has 2 RPKI servers. These are the 2 RPKI servers that we already configured and are already working. These are the RPKI servers that each of you will use for the purpose. Will be connecting your border router with the RPKI server to download all the ROAs, all the information of origin containing the autonomous system that is authorized to originate the prefixes of this laboratory. For those of you who haven't yet been able to access this, because some haven't got this far, once you access here with your username and password, if you click on the first link where you have lab, that will display a website with a large number of links. These are all the instances of this laboratory. The one what we're going to use now, once again, is the one that is the interconnection and RPKI practice guide. We have the one in Spanish, Portuguese, and in English, which is the one, the third one starting from the bottom. You can follow each of the 3. They're exactly the same, but in the respective languages. I'm going to use the one that is in Spanish, so I'm going to click in the guide in Spanish. This will be the practice guide for this entire session. I was saying that this is the network that each of you has, and then in the blue network, the one under the traffic exchange point has a device which is CLI. That is a client. That's a client that we're going to use to do a sort of a trace route to check out what is happening according to the routing policies that we're going to apply in this router. So we're going to verify that everything is up and running, that we're properly accessing this through our router to the internet. And we're going to use this to detect once we are under attack, to identify what type of attack this is. We're going to use this to verify that the mitigation mechanism of this attack using filters based on our PKI work correctly, and that everything is routed normally once we mitigate this attack. So the client will be used like a computer from which we can visualize the trace routes and so on. So let's start with the practice now. Everyone's all set? Any questions so far? Someone couldn't reach this stage? Raise your hand if you have been able to get this far. Otherwise, you won't be able to do anything in the practice. So speak now. Okay. Colo, could you help them out? Santiago will help you to get to this stage. So we're now going to continue advancing. How can we access the router? You click on the router. I clicked on the letter of the lab. It won't work. You have to go to the screen where you had the structure of the network and click on the router. Wait a couple of seconds, and this will display a new window of the browser with a command line in order to access the router. There we are. Was anyone unable to access the command line? Anyone? So the two are busy. Just a second. Chicho, Erika, maybe you can help them.
Raise your hand again. Could everybody access? Just a minute. Somebody will assist you.
Puedo acceder al router.
Sylvia, there's somebody who couldn't access the router. Raise your hand. There. Once you're here, then we're already in the command line. If you administer routers often, you're familiar. And if you haven't, well, welcome. What are we doing now? Then we'll follow the practice. We'll explain what we'll do. If you're already familiar, wait until, even if you know it, wait until we explain anything. And then when we say that we're to implement the command, then let's do it all together. If you are in a hurry, you may be left out. So let's go back to the practice.
Entonces, la primera parte de la letra de la práctica.
So the first part, we're going to explain a bit. As it's already, as the RPKI Fort validator is already validated, we're going to explain its configuration, and I'll walk you through some parts of the configuration. Santiago, your turn. If not, I'll help you. You can also go down and see where it says verifying the configuration of the RPKI Fort validator. Of all the potential RPKI validation, we used a Fort validator we use 2 validators. Why 2 and not just 1? This is a question for you. Who wants to answer? What happens if the validator that we have fails and we have only one? Well, it may be nothing. Maybe nothing happens. If nothing happens, but it may be a disaster because the things. If I have no validators, if I was applying filters, I will no longer filter because I won't have an updated validation. So we should have at least 2 active. So it's ideal to have 2 and different softwares. For instance, one Ford and one Routinator. But why 2 different softwares? Because you would have security problems or bugs or not. The odds for one software problem to be present in all the validators at the same time is very low. So the idea is to have 2 with different softwares. The reality is always different. If I want 2 softwares that do the same, it's like handling 2 different validators of 2 different routers. First of all, I have to learn how to use them. They operate different. So operating 2 types of software is not the same as just one. So even if the recommendation is, well, it would be wonderful to have 2 different softwares. Having 2 different softwares means administering 2 different softwares, and that's not always possible. I may not have the people skilled for that, or I don't want to waste the time and money to train them to use 2 softwares that do the same thing. The best is to have redundancy, but if it's 2 of the same software, like in our case, that's okay. So the key thing is redundancy and not the multiplicity of softwares. So first redundancy and then, well, Colo, you can explain now. Should we share the screen? So let's go on with the tutorial. And now we'll see the Ford validator that is maintained by LACNIC. And what we're going to see is a configuration that's very simple. We see this quickly, and then we'll go to the routers. In this case, what you have is a JSON format and different fields. Those fields, we'll see the TAL that is important is when you start a validation. And then we have, for instance, the configuration related to the server. That is, the validator will be a server that will be listening to a port, in this case 323, and there'll be some parameters that will tell the router what to do to request the ROAS again, or to discard them, or to try again. If you look at it, those that are the intervals and the parameters that say validation 900, refresh 900, retry, 600, expire 7200. These are the parameters that the router receives, so that after a certain time it will revalidate and refresh the cache. And after a certain time, the data obtained from the validator will expire. Then you'll find, then they will write the log, how the process occurs and the potential errors, and the strategy where you can synchronize against the RIRs. So you may be aware that the validator will download all the prefixes in the ROAS in the 5 RIRs, and will use a protocol. In this case, we are using rsync, but you can also do it through HTTPS. And here you find a file where you write all the ROAS that were obtained from the RIRs. Basically, file TAL is a file that is present in all of the RIRs and allows the validator to start the process of bringing the ROAS. Those 5 RIRs, the files are available, and that is what the validator downloads, which of the RIRs. After downloading that, the startup process, this is important. When you're running Ford for the first time, you have to wait a minute until it can obtain all the information of the RIRs. Once they generate all the ROAS, only then will it offer it to the router. So when you execute this, what Ford will bring all the TALs of the different RIRs to start the validation cycle. When the cycle is over, then the ROAS will be available for all the prefixes that the router will incorporate. There you have an example of how it works. You see that they are updated because of the date when it brought them. It stores them in the directory that we gave it for this parameter, and then we can, for instance, and then these are the prefixes that you will incorporate in the log. You see how it evolves. So you have to wait until the first cycle, the validation cycle, is completed. So we'll have to work in the console. There I'm going to share. So we'll go back to the chart where you have the topology. You have it live. We're going to press on CLI and you'll see the console of a Linux. If you're not there yet, let us know and we can help you out. What you need to see is a tab like this one in your browser.
So, have you all got here to this stage? So let's go back to the practice. So we're going to now execute this command, sudo apt install librtr 0. So with that, we're going to install a library of the RTR protocol. The RTR protocol is the protocol that establishes the communication between the router and the validator. And now we're going to simulate using a command as if we were the router. So we're going to go back to the practice. And we're now going to run this command, RTR client, etc. We copy that command. And we execute that. So we're now going to do as if we were an RTR client, which is what the router does, and then connect to the validator, and then have all the available prefixes. So what you can see over here is what we were just explaining. In other words, you start with a connection, and if you pay attention over here, there are a whole set of parameters that the validator communicates to the router, so that these are taken into account whenever it's going to connect and request the ROAS. So once that command has been executed, we're going to do an ls, and then we have a ROAS file, which is the CSV. We can see that over here, and we can see it with the more command, and you'll have all the prefixes that are here that are validated and that are registered in the 5 RIRs. So what you can do over here is to try and see if at MILACNIC you already validated the prefix. You can check this out over here. For example, let us try with 1. The autonomous system 28,000. And there we have all the prefixes that are related, that are originated by the autonomous system 28,000 with the maximum prefix length. Maybe you wish to try with your ICs, and we're going to execute a line counter. So there it showed 690,000 lines of prefixes that are validated. So you can look up this by autonomous system or by prefix, by your prefix, to see whether that is included in this ROAS file. Any questions so far? Did you all get this far? If you have any issues, please let me know. I will now give the floor back to Nico so he can continue with the rest of the practice, and then we'll be assisting you.
Continuando con la práctica.
So let's go on with the practice. Just bear with me a couple of seconds. And I will share my screen. Here we are. There it is. This is what you just did with Santiago. So checking the visualization using the RTR client. What we're going to do now is to talk a little about how the central router has been configured at the traffic exchange point. You don't have access to that router. That's why we're going to explain the configuration of the central router, and following that, we'll have a look at the initial configuration that each of your routers has, and we're going to start with the configuration. The central router at the traffic exchange point. The central router at the traffic exchange point is an FRR2 and basically has quite a basic configuration, although it might look quite complex. You have the central router with two interfaces that are the ones over here. FH0 of the traffic exchange point is the one connecting the router of the traffic exchange with the backbone of the traffic exchange point. That red line that we have on the schematic representation, that is the one that is connected to the ETH0 interface, and the interface WG0 is an interface connecting the central router of the traffic exchange point to a real router of a internet access provider. That is the one that is connected with the central router of the traffic exchange point that we control, and it receives from that internet access service provider the complete routing table. The central router of the IXP will only, once you establish the BGP session with that central router, only then when you receive a partial vision, sum of all the internet routes, the ones we select and the ones that we're going to be using during the practice. So following that, once you have those, we have already pre-configured the central router. You'll have all the BGP part of the central router, which has been configured. The central router already has the BGP sessions configured with each one, each one of you, waiting for you to do the configuration on your side. When you do the BGP configuration on your side, then your router will try to establish a connection, a TCP connection. Your BGP works through a TCP connection. So first you establish a TCP connection, and then you can check the BGP traffic to that connection. That has already been established in the central router, awaiting for you to do your router configuration. And that is a general configuration of the central router. If we scroll down to the description of this practice, over here we reach this side, verifying initial configuration of the porter router of the devices. These are your routers. This is initial configuration that each of your routers has. Now, to make this a bit more interesting and starting to execute commands, go to your router, and if this screen was closed, it might be that you are seeing this. If you see this over here, don't worry. Just close that little window in the browser, and then you go back, you access your own router. So all along the practice, if this happens to you, that you get disconnected, I think timeout is about 30 minutes. So if you haven't done anything for 30 minutes, then the router will be disconnected. But the entire configuration you did with a router, the router will continue to work, just the connection crashes. But you can log in once again, and you don't lose anything. The router won't lose that configuration even if you get disconnected. So we're connected to the router. We're not going to explain all the specific commands for FRR. For those who are familiar with FRR, are already aware of how this works. And if you're not familiar with FRR, FRR used to be called Quagga previously. This is an open source project of a soft router. And the CLI, the interface of the command line, is very similar, almost identical to the configuration commands of a Cisco router. Those who are used to configuring a Risco router, the XR series, not that one, but the previous series, the XR is different. So this is transported to here. There is a reason. I think the Cisco people already. This is because of many people that are used to use the Cisco series. So we're not going to invent something that is totally different. If we can use the same configuration command. So the same way of configuring was applied again. And I think some of the FRR developers at some moment also worked with Cisco. Now, to visualize the configuration in FRR router, you execute the command show. You can abbreviate the commands. Instead of writing show, I write just part of the commands, sh space run, show run, and you click enter. There you have the entire configuration, and you can scroll up in the screen and see the configuration of your router. And if you pay attention, it has pre-configured some default routes, one for IPv4, which is 104.61, that's the default gateway, and one by default for IPv6. Don't change any default route configuration, don't add any, don't modify any of the interfaces, because that, once again, this is a simulation and there's no out-of-band management. So if you cut one of these branches, you'd get disconnected and will never again be able to access the lab. This is up for you. If you modify or change the configuration of the route or anything, you're out, and we won't be able to help you because we won't have enough time to get you reconnected. So don't change anything. Be careful, particularly those techies. So these two default routes are the ones that connect the router with the outside world, with the internet, and through which you are now connected to manage that. And then we have the configuration of the interfaces. Remember the blue one and the violet one and the green one and so on, and also the red one. Well, these are the interfaces ETH0, ETH1, ETH2, ETH3, and this shows you which network this corresponds to. And this coincides with the network diagram that you have in the other screen of your browser. So let us now continue. Let's scroll down once again. And this is a basic default routes, which allows you to connect to the router and go to the internet. And of course, these are the ones that you provide your access to the internet, to your client, and also to you. And the 4 interfaces, that is all. Nothing else has been configured in this router. And there you might find RPKI, at least in mine, at least in yours and mine, but I think in yours it should also be there. This is just that the RPKI protocol is enabled in the router, but nothing has been configured there, so the RPKI is not working. The router is doing anything at all. It's not speaking to any validator. It's as if nothing has been configured regarding RPKI. And if that command wouldn't be there, it's exactly the same in this case. So this is the configuration that you have. We're now going to do the configuration of the router. Let's now go back to the description of the practice. Let's scroll down, 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 until we get to the part, scroll down a bit further, until we reach here. We add some route maps and the access list that we'll be using later on. So I now give the floor back to Silvia, who will continue with the configuration. Thank you, Nico.
This is a message for everybody. If you have any doubts or comments, or you thought that you had to do it otherwise, or if you know that it can be done otherwise, raise your hand. This is interactive. We don't mean it to be boring. We're going to be here all afternoon, so let's have fun. The idea here is to share our knowledge. Thank you, Nico. I wanted to tell you that, well, we want you. We know maybe Nico goes too fast and you got lost. If you have any questions, do not hesitate to raise your hand, and we'll be by your side to support you. Now, let's So let's check precisely the first part. Sharing the screen. Can you see the screen? Can't you see my screen? Thank you. Just to remind you, in addition to what you just heard, what Nico just explained was how to configure what we had in our border routers, and now each of you is in with you have the router you were assigned. We have several interfaces, and now we'll check them one by one so that you may see the connectivity. So we are going to have a BGP session with the border router. So that you may see a LAN, an internal, and so let's go on with the tutorial. So you verified this, and we'll start checking what we'll need, the access list and the roadmaps, so that we can apply to our BGP sessions. Remember that these filters are the ones that help us with the security in our machines. So let's copy and paste for each of your machines. So you may see that we have the configuration of a prefix list, the filters that are handled in BGP for IPv4 and IPv6. So we'll have an access list, and you're going to match with our RPKI validations. So we have configured the two validators. One has a better preference than the other, because we must have a primary and a secondary one. So we copy and paste in our router. We enter in the configuration mode. I think I'm going to stop sharing because I want to enlarge the fonts. So now I'm going to start sharing in Zoom. There I'm sharing again. Apparently it's difficult to see it. Now it's better, right? So we were checking. We want to look. We go in with a global configuration mode. Remember that we configured the filters globally. So now you have this part of the configuration. Once you've created the roadmaps, what's next? We have two BGP sessions, one for IPv4 and the other for IPv6, right? Each of us, we have we've been assigned an autonomous system. Now it's going to be a private AS, and we are going to use it depending on the group I was assigned to. For instance, 10, it's 65010. If I'm in group 50, 65050. So you'll each enter your BGP session through the router BGP. So first we enter the global mode, configure terminal, and then we were in the global configuration. We did the filters, the roadmaps, and now we'll go into router BGP with our 65010. Well, in this group, I was assigned a group 02. Remember, here you have your group. So, for the router IV that we had to configure, so that we will assign it to a router ID, we put it, instead of that X, we'll put the number that belongs to our group. So we'll do that, and each you will do it with your own. Go ahead, Nico. A clarification, because this is something that is confusing sometimes. When Silvia explained the autonomous system that has the ending of the group, make sure that it starts with 65,000. If you are group 1, it's 65,001. And if you're group 52, it's 65,052. 65, and then the rest of your group. Yeah, 65, 0. But if you're group 1, and it's 65,001 if you're group 1. Because if not, the central router won't be able to establish a connection with you. Right. Thank you, Nico. And so we'll have the configuration. We'll do what we mentioned earlier for a BGP sessions for control of IPv6. And here we're going to do peer BGP with the border router. Remember that we have the border router that Nico is the administrator, and so we'll also do the part of IPv6 and the same to a neighbor that is autonomous number 65,000, that is 65 and 3 zeros. And then in the address family in IPv4 we are going to activate each session. So start doing it, go step by step. We're going to do this, obviously. We're going to copy and paste. However, I want to mention that after we get into each of our families, remember that we're going to apply each filter to that BGP session. So we have a roadmap of all inbound and outbound IPv4, but for IPv6 too we have those two filters, all IPv6, all inbound IPv6 and all outbound IPv6. So if you want to go faster, well, you're going to have some more time in the automation part for Colo. So once we've configured in the address family of IPv4 in our RIR, and we have it for IPv6, with the command go through this. We'll check it. IPv6 and unicast. So this you can check. Exit. So that we can check with Joule, BGP. All the BGP sessions give us a summary of what we have here in our IPv6 session. We called it IPv6 plus unicast. And here it shows us the fusion of BGP that we have through this prefix. And to our autonomous system 65,000, that's the border. And we have this session. Here it shows us the time. And here it says the total number of the prefixes that we are receiving through this BGP session. In this case, it's 34 prefixes. So after this, what we are going to check is the status of the BGP table for IPv6, and I do this with the command show BGP IPv6 unicast. So we test it through our router. And it will give us a listing of all the prefixes. So here it says 35 prefixes that are being announced. That is, that we are receiving of the border router, of the main one. So here it gives us a chart, and here we can check the origin and the path of each of the prefixes that are being sent. So you read the path from right to left. So the first autonomous system is the one that is originating it, and it is followed by the one that's passing it. In this case, this path has 3 autonomous systems: the origin, the one it passes through, and the one it's sending. In this case, it's 65,000. And so here again, we have each leg, each segment. I don't know whether you see it, but there's something important that I'd like you to check, because this chart, this BGP chart, shows you whether the segments are valid. We haven't seen the application yet. So what I want you to check is that if it has an asterisk, then these prefixes are valid. And if we have this sign, greater than, that means that this is the best route that you could have to reach those announcements.
So, checking the tutorial that we have over here, we can see that now we're going to do a configuration that we need to run those RPKI validators. We have to connect our router with the RPKI validator. If we scroll back rapidly, you will note that over here we have an RPKI validator number 1 and RPKI validator number 2. So this is where we're going to start now. We're doing some magic. And before giving the floor to Nico, I want you to pay attention, because we're going to do some changes and things that we would like you to help us think to see what is happening. And for the 2 winners, we have a Mexican gift for you, which is chamoy. And This is because I'm from Mexico. So we're going to be looking at that. We're revising that. So let us run the validator part. So if anyone needs any assistance, please let me know. So I'm going to share my screen now.
Yes.
So let us resume from here. Like Silvia was saying, let us connect our routers to the RPKI validator. Just a couple of clarifications and review of what you saw this morning with Guillermo and with Erica, and you might also know this too. Connecting the router to the RPKI validator does not imply changing or modifying nothing at all regarding the routing policies. This is a question that sometimes comes up, particularly with those who are not too familiar with RPKI. So if I connect my router with the RPKI validator, it starts filtering things. Nothing happens at all. And the only thing that it does is it connects a router with the RPKI validator. So the router, every given period of time, this is part of the configuration and it has been set up. You can modify that, but it can be modified. At a given time interval, our router will connect with the RPKI validator and will download from the RPKI validator the validation status of all the blocks and of all the prefixes, the ROAs that are contained in the list that is generated by the validator. So the validator obtains all the ROAs following the entire process from the 5 regional registries. It gets them from there, from the regional registries or wherever from. It has all the ROAs, it processes these, and it then generates, as you saw with Santiago earlier today, you executed a command to do that query and to download that information of the RPKI validators. So you have a list, a file, a validation file. Basically what this contains, those blocks that are authorized to be originated by which autonomous system. This block, this autonomous system is authorized to originate this. This other IP block is authorized by these autonomous system or systems of here, and so on. This is a list that shows you the IP block and the autonomous systems that are authorized to originate those. I can include several IP blocks in the same ROA and several autonomous systems. Yes, you can. Is that advisable? No, not at all. The recommendation is to create one ROA for each block. This is because if you have to change a block in the future, and that block is included in a group of blocks, you have to modify the entire ROA. But if you have blocks each for one different ROA, then if you wish to stop validating it or if you wish to modify it, you just create a new ROA for that block and everyone's happy. But does not affect all the others. So the recommendation is to always create one ROA for each block, not include more than one block in a ROA. And of course, associated to that block, you do have to include all the autonomous systems that are authorized to originate that block. It could be one, it could be more than one, because maybe your block is authorized by several autonomous systems. For example, if you have an Anycast cloud and a DNS service, this is a typical case where one same block that has the IP addresses and the authoritative DNS service could be originated from more than one autonomous system. All autonomous systems, once they have a copy of your DNS server, that is one case, a very common case, where you might have more than one autonomous system that can generate a block. And there are also other cases for CDNs, for example, content delivery networks. The same blocks might be originated by more than one autonomous system. If you have an Anycast cloud or some system for load distribution from a CDN that requires to have more than one block published, or advertised to the internet from more than one autonomous system. So once again, connecting the router to the RPKI server only adds information to the router so that I can visualize this. It won't execute any type of policy. Nothing else will be done compared to what the router was doing already. How do we configure this? How do we connect the router to the RPKI server? This is quite straightforward. Using this configuration over here, we copy this configuration from the script, from the instructions. This is exactly the same for all because the RPKI servers are the same for all. So what is this configuration? First, it says RPKI. So it enables in the router the RPKI protocol. This has already been enabled. You will recall that we looked at the router configuration. This appeared at the end. But nevertheless, you have to include it because this configuration has to be entered in that block. The first line is RPKI polling period 300. That 300 is in seconds. This will tell our router with what frequency the router will contact and download the information from the RPKI servers. This here it's 300 seconds. Every 5 minutes, my router and your router, each of your routers, will download the entire validation list of the RPKI server. Typical question: 5 minutes, 1 minute, 10 seconds, every 2 hours, 1 week. What is the reasonable frequency? There's just one answer to this. But what you have to bear in mind is that the validation information for the RPKI doesn't change very frequently. When does this change? When someone modifies a rower, creates a new rower, or revokes a rower. So it's not that frequently, it shouldn't be that frequently that this changes. So 5 minutes is a reasonable time. The lower the frequency, the more frequently the RPKI servers will be consulted. If you have bought a router in a medium or a large organization, you might have hundreds or dozens of routers connected to your RPKI validators. So if that would be the situation, instead of have 2 RPKI servers, you can have groups of RPKI servers, or say all these routers consult this server and all these consult this other server. You can play around with the precedence. You can put different precedents in different routers so that some by default go to one server and others go to another servers, and there's a load balancing between all the RPKI servers. You might have a cloud, or you can do many things. Less than 5 minutes. Well, the lower the frequency, the more often the RPKI servers will be contacted and your routers will be occupied following this process. If put 10 seconds, every 10 seconds my router will be checking information that is likely not to change. And this is like excess, and I'm occupying my router unnecessarily in that task. So you have to really play around with the times, with the frequency. In most scenarios, maybe 5 minutes is too much, is too little, too frequently, maybe once an hour. But if the frequency is very high until the next period, when the information is downloaded from the RPKI server, then the router won't even learn about this. The router will learn this once the query has been done. And that's not the only timer we have, because the RPKI server, if you looked at the configuration earlier on with Santiago, the RPKI server has a frequency whereby the validation table is generated. So we have to play around with all those times. And then the other lines are those that specify the servers and the preference. Preference 1 is the one that finishes in 70, and preference 2 is for the one that ends in 71. These are the IP addresses of the RPKI servers. We put this in version 4 because at least until some not so long ago, FRR didn't accept having an IP6 address for these, but you can even put a domain name if you have DNS, or a domain name assigned to RPKI. So we're going to try and use the one that has the lowest preference. Your routers will be first checking the 70 that has preference 1, and if you cannot do so, you'll try and contact the second one, and otherwise you won't have the validation information. You can add as many as you wish. I don't know whether there's a limit to this, but the limit is larger than what is regionally possible here. You can add 3, 4, 6, I don't know, play around with the configuration. Thanks, Santiago. I'm told I'm speaking very fast. So we copy this configuration. We enter the configuration and we paste it over here. To access the configuration, let me remind you that the command is conft so that you can all view it. And I paste the configuration here for RPKI. This is a consultation period, the polling period. So we put exit twice. To exit here. And then we're going to do a query here. Visualization of the configuration of the RPKI validator. They have several things that you can do a query for. Let's first execute this command, show RPKI cache connection. This command over here. Our show RPKI will display the status, the connection status. There's just one group of configuring RPKI. You can set up different RPKI configuration groups. So the one with preference 1 is the one that is in fact connected. So my router is connected with server 164.070 RPKI, and that is where you will be downloading the information. If we visualize once again the BGP table, do we have it in the script? Yes, it's over here. So let's visualize the BGP table and then the specific prefix. If we can visualize once again the BGP table, we put here show BGP IPv6 unicast, or just show BGP. Oh, we cannot do that? Okay. Okay, that's a detail, right? That's a little detail. The thing is, I didn't follow the practice, so this might not work if I don't have the BGP up here. Just a couple of seconds and I'm going to configure this very rapidly. I didn't do my homework. I was explaining this and I forgot to configure this. So Nico is doing a very fast summary. He's configuring the filters that we had mentioned, the prefix list, the route maps. Now the BGP sessions. Now very rapidly. The IPv4 sessions, IPv6 sessions.
There, if you see the BGP table, let's see it again. Go on with the practice. You put show BGP. If you execute show BGP in the FRR router in the new versions, by default, it does the same as show BGP unicast for IPv6. So you put show BGP and notice that here you see the BGP route tables, But now you see more information. If we go to the beginning of the BGP table, you see that in the reference there's a line that didn't used to be there. So it says RPKI validation codes. And when there's an I, it's, well, there you have valid, invalid, and not found. Valid when there's a ROA that matches, that corresponds with the route exactly. Invalid when the origin, the autonomous system that appears at the beginning of the CPath, does not match the ROA. That is, that somebody is originating a block with no authorization because there's a row that says that that AS is not the one authorized, and so that's invalid. And not found is when that block has no ROAs created. So there it will be not found because it doesn't exist. So here you see the validation status. Now for each of the routes in the BGP table, it will appear as valid, invalid, or not found. So remember that when I did the validation, we saw the BGP table, we would just see asterisk and greater than. And now the difference, as Nico said, we have the services of the RPKI servers that have been activated. So there it will appear as V, I, or N. Valid, invalid, not found. So far we've added the validation status. So the router won't do absolutely anything. By default, it won't do anything. If I want to do something with that information, I have to configure it. I have to give the instructions. So somebody can say, oh, but you're adding too much information. What's that? What is it for? Well, I worked in many years in operations, and this is very useful. The RPKI protocol did not exist when I worked in an operations system center, and this information was not available. Why is this very useful if you're trying to clear something? Because it shows me the validation status directly by it. Because if somebody is hijacking the route, or somebody injected a prefix in the internet with no authorization, I look at the BGP chart table and I see a block, and instead of a V, I see an I of invalid. I know what the problem is. So I won't have to start wondering, is this AS authorized, and I have to go to who is, etc. And they, in the meantime, they are pressing you because the manager is saying everybody's without the internet, everybody's complaining. So just by installing an RPKI server with no filters whatsoever, even like that, it adds you very useful information for the people at the operation centers. So you're going to use this info when you need to clear a problem. So, and this changes absolutely nothing in the routing policy, but it's very useful for operators. So install an RPKI server, connect the routers, and use this just to make it easier for the operator's life. Then if you want, so what we'll do now is, following the guideline, we'll go to this part of the guideline that says we are going to check a prefix specifically. So now in the practice, first we are going to see the status of a prefix specifically, and then we're going to use the results of that prefix for the practice. So we are going to use this one here, prefix 2803 9910 8000 1, and that we're going to use that for the future in these minutes. So we won't analyze the entire BGP table, but just for these prefix. We're going to focus on this prefix. So we'll execute this command, show BGP IPv6 unicast and the prefix itself. So we copy this, we go to the configuration, and we execute that command. Show BGP IPv6 unicast and prefix. There, that one. And notice the information that appears for these prefix. First, the question. I shouldn't ask yet, right? Now, you won't get any prizes now, but please tell us, what is the autonomous system that is originating that prefix? So 65135, that's easy because BGPath to read the origin. We read it from right to left. The CPath says 65,000 and then 64135. And if we look at it from right to left, that means that the AS that is generating is 64135, and then it goes to autonomous system 65,000, and then it doesn't appear in the CPath because it enters the autonomous system. And our autonomous system doesn't appear in the CPath. It's more to the left, but it won't appear there. Then, what is the status of validation? It says valid, right? Because if we look at the end, it says valid. Why is that? Because our router is connected with the RPKI. It's checking this prefix. It's listed in the validation list. There's a ROA for these prefix, and it says that it's correct that the autonomous system 65 or 64135 to generate this. So if I have to send information of a device to this network, I'm going to try to make it reach 64135, and there are no routing problems, so everything is fine. So the next step, what we're going to do now is to use that prefix, and now Santiago will explain, and we're going to do a trace route, and we're going to see the path that a packet that I sent from my device, the customer's device, from your customer to that prefix, to the machine that has that prefix. What is the internet path that it will follow? How many hops it will have to go through until it gets to the destination network? That is this one. What is the destination network? I don't remember the info there, but the destination network is this one here. That prefix, according to the BGP table, is here. Any information that I send there, we're going to see how it gets to that destination. So we go on analyzing this prefix. We'll use a command that many of you are familiar with. That is MTR. We'll go to the console and we execute MTR. we're going to reach an IP of that prefix that you just saw with Nico. And what we're going to do is to have it run. We'll leave it running, and while it does, our colleagues will do something and we'll see what happens. So let's leave it there running, and now I'll give the floor to Sylvia. She's the bad guy, the bad cop. So you can also do this in your test. Remember that in the layout, in the model, just by your router, you had a customer server where you can try this, and you can do this MPR test to see how the different steps occur. So now we're going to do something, and I want you to pay close attention because I want you to see the exit of this command and what may have happened. This is something of what happened in real life, and more often than you would think. And very often that has a negative impact on many services, and this is one of the problems. This is one of the reasons why we are giving this tutorial, so that you'll know what you can do about it. So I'm going to do something, and hopefully you will notice what's happening, what the behavior is, and who it is that's causing the problem. Yes, you go directly into your customer, or here in Callers Customer. So let's do something. Machiavello is here because we want to damage the behavior of our network. You may notice that there's a change in the MTR. If you press on the R and you see MTR, wow, look at that. What happened there? Something happened to all of you, right? So could somebody tell us what is happening? So we see that the prefix, the RPKI, is no longer valid. Oh, you're going too fast. So what is the root cause? What? Probably they removed it. The prefix, no. No, good try. I'm Claudio. They changed the C path of origin, 65002. So that's a different ASN of origin. So what if we look at the route, you see that the path changed. So he looked at the route, and he did a show BGP of the prefix, and he sees that it was originated by another AS. I don't remember, 64 something. It was 64135. Yeah, so now initially it was being generated by 64135, and now it's 65003. And how do you call that? Hijack. It's hijacking the route. That's exactly a hijack. Somebody else wanted to say something?
So you won one of these. It's not strong. It's a hot Mexican sauce, maybe.
Decía que cambió las.
So the ASN was changed. Once again, we couldn't hear you. The network you see in the BGP is a more specific mask. It's a 48 and it used to be a 34. He apologizes. He says he cannot hear. It's a /48. And the specificity of the network changes. It's not the same network. It's a more specific network, /38, and now it's a /48. Perfect. So the specific thing, that is why that is being preferred. Compared to 65002, I think she's not using the microphone. So that is what normally happens when we do we have a route hijacking, either on purpose, and that would be a cyber attack, or by mistake. So there are many cases that have been documented of intentional cases and others that are accidents. But accidents do happen. So in this case, I am 65002. Sylvia is a cyber criminal, and as a Mexican, I am famous for hijack. Well, that does sound awful, but that route has been hijacked. That has happened, and it's quite common. In fact, unfortunately, as bad practices in the ISPs, saying that only they can provide a solution or access to the internet. That has happened sometimes. And when I used to work for universities, I had to conduct tests with the NOG of the universities and to check this and provide support, because problems were the ISPs sometimes. But now I will remove this hijack. Not yet, not yet, not yet. Okay, let's do the following. Before going to the break, let us apply the RPKI configuration, which is just 1 line, and to visualize a prefix, you can solve that. The break was at 4. We're going to get 5 minutes. Prior to the break, we have a 30-minute break, and then we resume with the practice session. Now, what we're going to do now, before going over to that section, I can share this over here, if you wish. I'm going to share my screen now. So we're going to now use the configuration we have in the router, those access lists that we had pasted initially, and the information we are receiving from the RPKI validator in order to generate a BGP filter. Now we're going to configure an action. I'm now going to do something with the RPKI information we received from the RPKI server. We're going to do a BGP filter based on the validation state. So this is to mitigate an attack. This is a real scenario. Someone hijacked our prefix, and because we have an RPKI server configured, what we're going to do now is to take into account the validation status and then filter from our BGP table this in order to remove all those prefixes that are invalid prefixes. So we go to the router with this aim, and we once again execute the command that visualizes the specific prefix. If we execute the same command that we executed previously, in fact, the AS that is initiating this is no longer 64135, but it's 65002, the AS that Sylvia has configured, who is the one that is generating the route hijack. And if you look at the validation status in your routers, that is invalid. So we're going to apply a BGP filter using route map that removes all the prefixes that are invalid prefixes from our table. So we have the clean BGP table with the valid prefixes. So with that aim, we will, in our router, access with conft, we access the configuration mode, we access the BGP configuration, router BGP, and your autonomous system. In my case, because I'm from group 1, I'm going to put 65,001. And once we're inside the configuration, the BGP configuration, we're going to go to the script of the practice, and we're going to execute the next command. We're going to enter. You have to copy this here, command by command. This line address family IPv6 unicast, going to access configuration, the BGP configuration for the IP6 session. And now we're going to execute this command over here, which is neighbor and an IPv6 address, which is the IPv6 address of its connection with the central router of the traffic exchange point. I'm going to change this roadmap. But now the BGP session that you have has a roadmap that is all in. This means that it allows everything to go in. It includes everything without any filter whatsoever. The RPKI route map, if you do show run, and if you look at the configuration of your route maps, one is called RPKI, that filters, identifies all those that have invalid status and removes this from the BGP table. So when applying this route map, our BGP table should be cleared of all invalid prefixes. So we copy this configuration, we paste it in our router. In our BGP configuration, we exit 3 times. You have to exit the address family, the BGP, and you have to exit the configuration mode 3 times exit. And once that has been applied, we now go back to viewing the status of that prefix, the command for visualizing that prefix. So what happened here? Because the BGP table now was cleared of all invalid prefixes, we only have those that are valid prefixes. Prior to applying this filter, the BGP table for that network, for that prefix, Crax himself, had 2 entries in the BGP table, one with the /32 network and one with the /48 networks. The /48 network is more specific, so it beat the other one. So that was, we had the route hijack. Now we eliminate the invalid prefix because the /48 network. The /38 was less specific and is valid, and it keeps this in the BGP table. So now our BGP table is correct, and yours is also correct. And if you pay attention, 64.135 is the origin of this network. It now is a /34, and the validation status is valid. So now we'll go to the client and refresh in the MTR to see what happened. Santiago, maybe you can share this so we don't take longer. We have no more prizes here, but we do have one final question prior to the break, and then who answers the question is the one who is going to take us to the break. Refresh. What happened now? What happened? We solved that attack? Did we or didn't we? No, we didn't solve anything at all. But the validation status in our router showed this as valid. So why did this happen? Why do we still have the route hijack? Nico, over there. There are microphones. You can, if anyone can explain this. If anyone has the explanation, can go up to that microphone over there and answer. We're having feedback. Let's see, check the microphones. My microphone is having feedback with that one over there. So what could be the explanation for this? You have to wait 5 minutes. No. You have to wait for the propagation time in BGP. By default, BGP, if you don't change the timers, it does an update every 30 seconds. More than 30 seconds have elapsed. If you refresh this, and also the hops, because this is a lab network, these are few hops. This could be the case, but you have to wait for that time, but that's not the real cause. Why is the problem still there? We mitigated, we resolved this in our router. Why is this still there? How does RPKI work? How does BGP work? I have information that I want to reach an autonomous system. I send this information, I forward it to the next autonomous system in the AS path. That autonomous system, what does it do with the information? The receiving router will look at its own routing table. Don't forget that the entire internet based on the IP protocol is not oriented to the connection. I'm not saying which path will be followed by the information. It is decided by each router. My router has applied the filter. But what about the central router of the traffic exchange point? Exactly, the central router of the traffic exchange point has no RPKI applied. It's not applying an RPKI filter. So no matter if in my router already cleared that routing table, once the router forwards it to the next hop, forwards this information, the next hop looks at the routing table, and the next hop is the central router of the traffic exchange point. The central router is not applying any RPKI policy. So in its routing table, we still have the hijacked prefix. So routing continues to work badly. For the RPKI to work, a policy has to be applied for the entire path, and that's a detail. That is why routing security not only depends on one player, not only on me. If I had multiple internet connections, applying this to my router, I just solve one part. But the rest of the path no longer depends on me. It depends on what the others configure. So everyone has to apply this filter. Now what we'd have to do is to access the central router, apply the filter in the central router, and when applying the filter in the central router, to refresh the configuration and to check what happens. So we're going to do that very rapidly now. I'm going to access central router, I'm going to apply the filter, and you're going to refresh this without changing anything to router to see if we can solve this, and we'll go to the break. So allow me to access the central router. We do have a prize here because this part is very important. It's important to apply RPKI everywhere. So Nico will do this now. I'm accessing the central router. Just a minute, allow me to share my screen to see what I'm typing here. Colon, allow me to share my screen. So there we are. We access the BGP process of the central router. The BGP is autonomous 65,000, and I'm going to apply the same filter that you had, but I'm going to apply this in the BGP session against Sylvia's router, which is that of group 2. So let me check where this is. So the BGP configuration has about 200 entries. It's not as simple as that of the other routers. I have to look up the BGP session for the group, for group 2. It's the one that ends in 2. This is one over here. So this is the one that I have to change. This is the entry I have to change. The central router allows all those prefixes published by Sylvia because it says all IPv6, and that roadmap allows all the blocks allowed by Sylvia, published by Sylvia, are allowed. So I'm going to filter the invalid prefixes. Apply that mechanism.
Entonces acá en vez de todo IPv6.
So here, IPv6, I'm going to apply RPKI. There, I applied it. Now, I'll check again that the configuration changed. If you look at this, now I'm filtering for the connection between IPv6 with Sylvia's autonomous system, that is 65002, and the inbound filter will remove all the invalid ones. And now I'll stop sharing. Click on R to see whether you could solve it, and I hope you solved it. If not, I did something wrong. Remember that the CPath was your router, central router, and the attacker's router. So we apply the RPKI filter, and in the central too, and now we should be able to restore the right path for that prefix. So if you click on R, you see, you solved it. You mitigated the attack. The attacker continues to attack, but as we all use the filter, we are mitigating the attack. So now let's go to the break. And then we'll resume at past. And Santiago will show us how to do this, but automating all these tasks. And you'll see how just a few commands, once you automate it, you can do this very quickly. You can leave everything here and go to a break and be back. I'll be here, somebody will be here, or if you want, you can take your laptop, because even if you do, you won't lose your connection. You just resume. No more passwords.